All right, kiddos, today's topic is to solve matrix equations using Cramers rule. This was a rule that was created before we had the technology that we've been using the last few days, where we just type the matrix into the graphing calculator, press the inverse button, multiply it by the constant matrix, and boom, there's all of our answers. So this, again, is an algebraic way to solve. Number one, if you don't have the graphing calculator to help you get the solutions. So in Cramer's rule, the first thing that you need to do is determine the determinant for the coefficient matrix. And remember, we can only do determinants for square matrices, so 2 by 2s or 3 by 3s and so forth. And the notation for determinant is what looks like the absolute value bars. And remember, you multiply the down diagonals and then subtract the product of the upward multiplying of the B and C diagonals. So that's our first step. The second part is where it is a little bit cumbersome and you have a little bit of work. For each variable, so for a 3 by 3, for the x, the y, and the z, we're going to set up an individual fraction, find a new determinant for a new matrix for each one of those variables, and divide it by the denominator will be the determinant of the coefficient matrix. When we set up our new matrix to solve for x, y, and z, whichever variable we're solving for, we are going to replace its coefficients with the constant values, whatever each equation equaled at the end. And then we'll write our answers as an ordered pair or an ordered triple, depending. We're going to do 2 3 by 3s using the graphing calculator, and then we're going to do 1 2 by 2 by hand, because usually that's a little bit faster. All right, so our first example, we have 3 equations: 3x plus y plus 2z equals 9, negative 2x plus 2y plus 3z equals 6, and 2x minus y plus z equals 8. So this will create what you see down below, a 3 by 3 matrix. And again, using that notation means to find the determinant of this particular matrix. You guys can copy the first and second columns and do your down diagonals minus your up diagonals, or in your graphing calculator, press second inverse, choose math, and then that first option is DET for determinant. And then from this point, you can go back into the matrix option, second inverse, or you can use the shorter method, alpha zoom, and create your matrix that way and substitute in to get the determinant. So pause, take a second, get the determinant of this particular matrix. Now that you're back, you should see that you do have a value of 19 for the determinant of this particular matrix that we are working with. That is going to be part of what we use in order to solve for x, y, and z. Okay, so here's our second step. We already have the determinant, and that's what I'm definitely going to divide by in each of the fractions. And remember, the original coefficient matrix is 3, 1, 2, negative 2, 2, 3, and 2, negative 1, 1. Okay, so in order to solve for x, each of the coefficients of x are in this first column. So instead of using those values, I'm now going to replace them with the constant values 9, 6, and 8, respectively, to complete the matrix so that I can find its determinant of the new x matrix. I'll finish out the remaining elements just as they are. So the first row is now 9, 1, 2. The second row is 6, 2, 3. And the third row is 8, negative 1, positive 1. So you'll notice I'm taking each of the x coefficients and replacing them with the constant values. Again, second inverse, math, determinant, type in your 3 by 3 matrix. In this case, the determinant of our x matrix is actually 19. So my fraction is determinant of the x matrix divided by the determinant of the original, which is 19. and 19 divided by 19 is 1. Okay, just stick with me if you're kind of scratching your head a little bit. So keep going. Now we are going to solve for the y variable. And you notice I'm going to color code all the way through. So I'm going to take each of these y coefficients that are in the second column and replace them with those constant values, just like we did with the x's. So now our second column is 9, 6, 8. Okay, I always fill that in so that I don't mess it up. And then I'm going to fill in the remaining elements. So first row is going to be 3, 9, 2. The 3 and the 2 for x and z are the same. Second row is -2, 6, 3. And the third row is 2, 8, 1. Again, we're going to find the determinant of the y matrix. Take a moment, press pause if you need to. This should equal -38. When I take the determinant of the y matrix divided by the determinant of the original, I get a value of -2. All right, hopefully you're kind of seeing the pattern and kind of seeing how this is going to work. So in our last set, solving for z, I need the coefficients of z. Those are in the last column, 2, 3, 1. I'm going to replace 2, 3, 1 with 9, 6, 8, each of their respective constant values. Okay, and now we're going to, again, fill out the remaining elements from the original matrix. So the first row is 3, 1, 9. The second is -2, 2, 6. And the third row is 2, -1, 8. Again, find the determinant of your z matrix, which works out to be 76. And when we take the z matrix determinant divided by the original matrix determinant, which is 19, we get a value of 4. So our ordered triple in this case is the x value is 1, followed by the y value, which is -2. And last but not least, the z value, which is 4. So it's 1, -2, 4. And there we go. We're going to practice it again in the next example, and then we will quickly do a 2x2 by hand. Okay, in this example, you don't have any of the stuff written out, so you're going to do all the pieces yourself. We do have 3 equations with 3 variables, so we need to find the determinant of the coefficient matrix, which is 3, 3, 3 for the first row, 5, 2, 2 for the second row, and 2, -4, -1 for the third row. When you find the determinant of this coefficient matrix, you should get a value of -27. So that again is what I'm going to divide by for each of the variables individually. Okay, sticking with my same color coding, all of my x's, those coefficients in that first column now get replaced with the constants -12, -17, and 20. The remaining elements stay as they are. So it's -12, 3, 3, -17, 2, 2, and 20, -4, -1. All of that gets divided by, or the determinant of that matrix, excuse me, determinant of that matrix, which actually equals 81, gets divided by the original determinant coefficient matrix, which is -27, and 81 divided by -27 will give us a -3. Okay, solving for y. Back to our green. We are the second column of variable coefficients, the 3, 2, -4, again in the middle, because we're solving for y, that second value, second variable, will be -12, -17, 20. And each of the other elements remain the same. So it's 3, -12, 3, 5, -17, 2, and 2, 20, -1. When we find the value of the determinant for this particular variable, y, its value is 225. Now, when we simplify this one, it does not work out evenly. That's totally fine. it will be negative 25 divided by 3 because everything is divisible through by 9. And last but not least, find the determinant of our new Z matrix. So we're going to take the last column, 3, 2, negative 1, replace it with those constant values. So the far column is now negative 12, negative 17, and 20. The other elements stay the same. Row 1 is 3, 3, negative 12. Row 2 is 5, 2, negative 17. And row 3 is 2, negative 4, 20. Again, the original determinant of the coefficient matrix is negative 27. The determinant of our Z matrix ends up being 198, negative 198. So negative 198 divided by negative 27 is going to give us a positive value. It doesn't simplify either evenly, so it's 22 over 3. So your solutions for this particular example are negative 3 for the x, and then negative 25 thirds for the y, and then for your z, it'll be positive 22 thirds. Now, if you change the y and z values to be decimals, they are repeating decimals, so make sure that you keep that repeating symbol. So it'd be, oops, wrong color. So for the y value, it would be negative 8.3 repeating, and for your z value, it would be positive 7.3 repeating. Again, they have to be repeating because they're repeating decimals. All right, our last example, we're going to roll through this one. It's a 2 by 2. We get to do all of this work without using the calculator. It says you can use scientific calculator, but we can do a 2 by 2 determinant in our heads. Piece of cake. So the coefficient matrix is 7x plus 2y, so 7, 2 for the first row, and 3x minus 4y for the second row. So our determinant is the product of the down diagonals, negative 28, minus the product of the upward diagonals, negative 6. So negative 28 minus 6 gives us a negative 34. That is what you're going to divide each of the x and y determinants by, so you can solve for where do these two lines intersect. Setting up our fractions, I'm going to keep my color coding the same. So the x coefficients, 7 and 3, now get replaced with negative 5 and negative 7. So in the x matrix, we will have negative 5, 2, and negative 7, negative 4. When you find the determinant, again, down diagonals minus the upward diagonals. Negative 5 times negative 4 is 20, minus negative 7 times 2 is a negative 14, so add those two together to get 34. So x determinant is 34. Original matrix determinant is negative 34. When we divide those, we get negative 1. There's the x coordinate of where the two lines intersect. And last but not least, now we're going to take our y and substitute the y coefficients with the constant values, negative 5 and negative 7. So our y matrix is 7, negative 5, and 3, negative 7. Multiply your down diagonals to get negative 49, minus, multiply the upward diagonals, negative 15. So negative 49 plus 15 gives us negative 34 for the determinant of the y matrix. We will divide that by the determinant of the original coefficient matrix. Negative 34 divided by negative 34 is positive 1. So the y coordinate is positive 1. These two lines intersect in the ordered pair or at the point negative 1, 1. Great job, guys. There is some practice on the following worksheet, worksheet H. There's several there. Pick a few of each type to try. Do the 2 by 2s on your own. Practice those skills, and you can definitely use your graphing calculator for the 3 by 3s. Not that you can't find determinants on your own, but it's cumbersome in itself. And then practice out, we'll review it, and then we'll be done with this unit. We'll have some review and practice before your test. See you guys.